So let's take a look at the preview here, and this is with the measuring the distance of the pin constraint, and as you can see we're getting these nice splits now and the blocks are separating. But I still think the bending, the angle is very high, and we're gonna tweak that. But I wanted to show the idea of using the distance between the various pieces to separate the constraints. And we can apply this to anything we want. We can apply this to the glue constraint or any other type of constraints we have. Now I'm going to do a few frame comparison. Obviously the sim is very different, but this is the new one. You see this nice crack here. And then if I go back to 0, you can see it's still holding up all the way through. It didn't let go that block. Okay, so with the new one, that got separated. So I definitely like having just a tiny bit of higher degree and using this technique to fracture things. Okay, so what I'm going to do now is I'm going to lower these guys. I'm going to set this to 0.0, and I'm also going to lower the length. I think it's 2 is high, so we'll go with 1.2. And the other thing I want to change is I want to change breaking of the glue constraint inside of here. So instead of let's call this glue main, and let's call this hard pin, and then this guy I'm going to set to -1. And inside we're splitting the pin and glue, and I'm going to use an expression here that uses the impact. So if the impact is higher than 50,000, let's say, we want to break the glue. Okay, that's my condition. And each constraint has specific rules to break. For the pin, I use the angle and or the torque, and for the glue I use the impact or the force. And in this example I'm going to use the force, and let's lower this to 10,000 to start with. I'm also going to reduce the number of pieces here, and let me rename this to 5. And I'm going to simply do that by deleting actual RBD objects. So let's copy this group. It's called toDel, and sorry. And let's delete all this. Blast them. The first Houdini 17 version release had a lot of issues deleting packed primitives, and it looks like it's better now. Okay, let's take a look. So it looks like the glue constraint, because yeah, let's do this, because the pin constraint was made based on the original geo. So what I'm going to do is I'm going to unpack it after deletion here and use that to generate the constraints, and that will give me the data that I need. Let's go inside. Yep. Okay, and let's hide the constraints. Cool. And we're going to test the breaking here. And let's hit play. Should probably move this guy a couple of frames so we don't have to wait. Or maybe we start the frame, yeah, we'll start the sim at whenever the feed gets close to the wall. Maybe frame 10. We'll start at frame 14 next time. And the reason I wanted to do the glue constraint breaking inside of SOPs, inside of being able to control that, is because I want to add a certain logic to it. And the idea I want to implement is after the glue constraint gets broken, I don't want it to just break like that. I don't want it to let go quickly. Okay, I want to convert that glue constraint into a soft constraint that will give us some kind of stickiness between the pieces. Okay, you see this with massive destruction scale or large scale scenes where you have a building, for example, and it's separating. It has a block that is separating from the block next to it, but it doesn't just let go. Okay, there's a resistance that holds them together. This is not the pin. This is after it broke. There is still some magnetic field connecting the two together. So what I want to do is, pardon me, after I break the pin constraint, the glue constraint, I want to convert it to a soft constraint, but I don't want it to keep that soft constraint forever. I want it to only be turned on for 4 frames, okay, and then shuts. And this way, anytime we break the glue constraint, first of all, it's going to calm down everything, and it's not just going to explode, even if the force is going to be crazy. And then during those 4 frames, it's going to still try to hold up to its original position, and this just adds another level of realism to the constraint. This example may not be, or I don't think it is the best use case for this, but I think it's going to help if you guys learn the technique, so I'm going to show it. And I think it's working pretty well. The main thing, this guy is not deforming as much because we removed a lot of pieces that were pushing this. Okay, so that adds to this as well. But I like this. And I think 10,000 is a bit high, so let's lower this to 2,000. And what I'm going to do is I'm going to create a soft constraint. Bullet soft attach. And I'm going to set the rest length to 1. And let's make sure we have that information here. So I want to compute the rest length. Okay. And after we scale it, the rest length for the glue constraint is perfect. These guys, they're fine. But after we scale the primitives, we want to fix the rest length. So this guy, we're going to set to 0. So f rest length is equal 0. And let's take a look, make sure. So yeah, all good. So that when we set it inside of not this guy, so that when we set it here to 0, it is correct. So we want that. That's fine. We're gonna set this to 1,000, maybe 4,000. I'm gonna set this to 5, and I'm gonna actually turn these back on because it's not gonna change much, but it may help propagate some of the constraint breaking with the glue. The main reason I turn these off is when I have a glue constraint that is a huge block that is connected together, I try not to use any propagation rate or anything like that because it doesn't tend to give the result. But for this small radius region, small regions, I think it's going to work fine. So okay, after we break it, the constraint name, instead of changing it to glue broken, I'm gonna change it to soft glue. Okay, this is my name. This is the soft constraint name. I'm gonna change it to that. And I'm gonna initialize a counter. So I'm gonna say count is equal to 0 here. And then what I'm going to do is I'm gonna say if the s at constraint name is equal to soft glue. If the constraint name is equal to this, I want to first increase that count by 1. Okay, that's what I want to do. And then, so let's say this happened once and the constraint name changed. And I'm also going to add the constraint name here. So this guy, I'm going to say if constraint name is equal glue, and if the impact is higher than 2000, I want to change the constraint name to soft glue. I want to set this counter, this attribute to 0, and then I want to check if the constraint name is glue. Okay, this is in a separate frame at a later stage. If we have anything that is with this name, we're going to increment this count on it. And then if that count is higher than 4, which means it has been alive for 4 frames, we're going to break it. So s constraint name is equal soft broken. Oh, nice. And then we're going to reset the counter to 0, which it doesn't matter, but we don't have to do it. Okay, so that's it. And then we're going to exit from this condition once and for all. So what I'm going to do, I'm going to move this up and think of it this way. Okay, I have a glue constraint. We met this condition and the force is this. It's now going to switch to a soft constraint, a soft glue constraint. We initialize this counter, and then the next frame, the next iteration, we have a constraint now named soft glue. This condition is going to be met. We are going to increase the count value that exists on it. If the count is not 4 yet, actually let's set this to 3. If the count is not 4 yet, we're gonna just move on. We incremented it 1 and we're not going to execute this. And then the next frame, we're going to meet this condition again. We're going to increase the count up until this becomes true. In that case, we're going to break the constraint by changing its name. Okay, so let's see why it's complaining. Error on unexpected end of file. Okay, so we're missing this bracket, and let's make sure we are getting the constraint name. Yep. So this is going to give us pin and then everything else, which will be run through this. And let's take a look. I also set the rest length. Remember, the glue constraint, it never stretches, so the rest length is going to be the same no matter what, and if it's broken, then it's going to change. I also want to keep that because it's very important for this guy, so it tries to go back to that initial state, because after the glue constraint is going to break, the distance is going to stretch, and we want to restore it back. So let's go back. I want to change the start frame to 14, so we don't have to wait. And let's lower the sim setting to 10 here. And I like to randomize constraint order because that helps with the stability of the sim in general. Okay. You can see, I think there is a difference already in all of this. With soft. So let's see. So I think Houdini is gonna quit. Okay, so Houdini crashed, and I'm not sure how this affected the state of the recording. I'll probably have to edit this and fix it, which is not a problem. And then I'm going to, let's see if we can get back to the state of where we were. I think we got everything got saved. Okay, and let's set this to 10, and let's check the memory. Yeah, memory is definitely fine. Maybe it's the recording tool that I'm using. I'm not sure why getting this memory issue. Okay, let's go back here. And I'm gonna go up and disable this, and let's reconnect the this guy. What? Attribute name doesn't exist. Okay, then connect it there. Cool. And I'm going to remove the delete, or we remove that. I'm gonna save this as v5, and I'll cache it for 120 frames and just 100 frames, and we'll continue in the next video after I do a preview of this. Thank you guys for watching, and see you in a bit.